Hello and welcome everyone to the interactive live session of the course Microwave Engineering. I am Susan Thomas. I am a PhD scholar at Electrical Engineering Department, IIT Madras. I will be conducting a 1-hour weekly session on Google Meet every Friday from 7 p.m. to 8 p.m. The aim of this session is to interact with you all every week, solving some sample problems and clarifying your doubts. The session will start with a brief summary of the video lectures and syllabus coverage in that particular week, followed by a tutorial session. Hope I will be able to keep you motivated throughout the journey of this course and help you attempt the weekly assignments of this course with more confidence. Let me talk a little bit about the course. This course on microwave engineering is intended to provide a foundation on microwave engineering to undergraduate students. This will provide an overview of application of microwave in communication. We start the session today. So let me start with some interactive polls with you. You can access the polls from the Google Meet. So this poll questions, I am launching the first poll here. So as an NPTEL learner, which of this category do you belong to? So I would like to know the audience here. So as are you a BTech student or an MTech student or a PhD scholar, or or a working professional who is a faculty in engineering college, or are you a working professional in industry? So please access the poll and let me know you as an NPTEL learner which category do you belong to. Yeah, thank you everyone for accessing the poll. So I understand we have a lot of different categories of NPTEL learners. Happy to know that. So let me go to the second poll. So this is a general question. Test whether you have an idea of what is the frequency range used by the telecom operators in India for 4G LTE band. So I have given you three options: 1.5 to 1.8 gigahertz, 2.3 to 2.4 gigahertz, or is it 4.2 to 4.4 gigahertz? So let me know whether which of these band. Let's see if you have any idea of the frequency range. Yes, as you see here, 2.3 to 2.4 gigahertz is the frequency range used by the telecom operators in India for 4G LTE band. So that was an interesting question. So let me move on to the course layout or the structure of this course. What are the contents to be covered in the course? So first is Introduction to Microwave Engineering and Transmission Line Theory, then Rectangular and Circular Waveguides, then Microwave Networks and Scattering Metrics, then Impedance Matching, Microwave Resonators, Power Divider, Directional Couplers and Filters, Microwave Semiconductor Devices, Microwave Amplifiers and Oscillators, Microwave Tubes, Ferrite Devices, Introduction to Microwave Integrated Circuits, then Microwave Communication Systems and other application areas. So let's move on to our tutorial session, Learn to Solve Problems. So this session is intended to help you to solve some. So let me start with the first question. For two given vectors A and B, if A dot B is equal to 0, the angle between the vectors is. So this is a very simple question. You all have the background of vector algebra. So very basic question from there. So the answer options are 0 degree, 45 degree, 90 degree and 135 degree. So let's see how we can solve this. So as you all know, A dot B is equal to A B cos theta, where theta is the angle between the vector A and vector B. So when I say A dot B is equal to 0, so I need to equate this to 0. So this happens when the angle between the vectors A and B, which is theta, is 90 degree. So the answer option is C, 90 degree. So I hope this is clear. So when two vectors are perpendicular to each other, we have A dot B is equal to 0. So let me move on to the second question. The electric field component of a plane wave traveling in free power 7t minus beta z ax cap. Which one of the following is not true? Option A, wave travels in the x direction. Option B, the magnitude of electric field is 5 volts per meter. The value of beta is 1 by 30 radian per meter. The wavelength is 60 pi meters. So let's see how to solve this question. So we have the electric field component here. So as clear from this, electric field is having a x component. So the electric field has only x component. So and the magnitude of that electric field is given here. So this is generally of the form E naught cos of omega t minus beta z, and this is a x component or ex component. We represent it with ax cap. So where this is the magnitude of the electric field E naught. So option B is correct because magnitude of electric field is 5 volts per meter. And let's see what is option C, the value of beta. So how do you calculate the value of beta? So from the electromagnetic theory, we have all learned that beta is equal to 2 pi by lambda, and we know that this omega is 10 power 7. So omega is equal to 10 power 7, which is actually 2 pi f. So or else we can write it like 2 pi into c by lambda is equal to 10 power 7. So this 2 pi by lambda is nothing but beta. So beta can be written as 10 power 7 divided by c. Where is c is the speed of light. So I can get this as 1 by 30 and the unit is radian per meter. So option C is also right, or this statement is right. Now let me see the fourth option, that is wavelength. So as we already seen here, lambda, the wavelength is 2 pi by beta. So 2 pi by beta is 1 by 30. So I can write wavelength is 60 pi. So the statement D is also correct. So let's go to the option A. Wave travels in the x direction. So as you can see here, this represents an equation of a plane wave traveling in the positive z direction. So the wave travels in positive z direction. So this is not a true statement. So the answer is option A. Hope you understand this. If you have any doubts, you can clarify. So otherwise, I'll move to the next question. That is question number 3. The electric field component of a plane wave traveling in free space is given by E is equal to E naught cos 10 power 70 minus beta z ax cap. Average power density in watts per square meter is given as. So to attempt this question, we must know what is average power density. So let me tell you, the Pointing vector P, or the vector which represents the power flow, is given by E cross H, where E is the electric field and H is the magnetic field vectors. So we can write E by H. So from this we get H is equal to E by eta. So I can replace H here. So P, or the power, can be written as E cross E by eta. Now let's see what is the average power density. So to get average power density, we need to use what we learned from electromagnetic theory, half into real of E cross H. So using this, we can write P average is equal to half into E into H, can be written as E by eta, or I can write it as mod E square by 2 eta. We all know eta is equal to root of mu by epsilon. So this is the permeability in free space and permittivity in free space. So this is the intrinsic impedance of free space. So rewriting this using eta, I can get P average is equal to mod E, or I can write it as E naught square also, because it's a magnitude, divided by 2. Instead of eta, I can write it as root of mu by root of epsilon. So this is the magnitude of the average power density. Now let us talk about the direction of the power density. As you can see here, electric field is in x direction and magnetic field in the y direction. So the power flow or the power density will be in z direction. So this is the direction of average power density. So looking at the options, it's clear that option B is the right option. Hope you understand this. If you have any doubts, you can clarify that. Or else let me move to the fourth question. The tangential component of electric field is 0 on a perfect conductor. So as we have seen in the boundary conditions when we learned electromagnetic theory, we have seen the tangential component. Say we have a perfect electric conductor. So the tangential electric field component ET is equal to 0. So this statement is true. So let me move to the next question. This is again a question from vector algebra, testing the knowledge of vector algebra here. The component of vector A along vector B is given by. So it's a very simple question, which is to get the component of vector A along vector B, we have to do A dot B. So we know Ax minus Ay cap is vector A, Ax minus Ay dot 2Ax plus 2Ay. So when you take a dot product, you get 2 minus 2, which is equal to 0. So component of vector A along vector B is 0. So answer is option A. Now let me go to the next question. Question number 6. Given vector A is Ax minus Az and vector B is equal to Ax plus Ay, the unit vector perpendicular to both vector A and vector B is given by. So to find out the unit vector perpendicular to A and B, we need to take a cross product of A and B divided by modulus of A cross B. So A cross B can be evaluated as Ax, Ay, Az, first row, and the second row we need to write the vector A. Vector A components are 1, 0, minus 1, and vector B components we write 1, 1, 0. So we can get this as Ax minus Ay into plus Az into. Now to get the unit vector Ax minus Ay plus Az divided by, so take the magnitude of this vector, we get it as by root 3. So this is the unit vector perpendicular to both A and B. So from the answer options, it's option B. So thank you all. That's all about the session. I hope solving these sample problems helped you to refresh the concepts of electromagnetic theory and vector algebra, which are prerequisites in this course. If you have any questions, you can answer. You can ask. I'll be trying to answer.